This is a demonstration of how to solve problem A1 in the applications for chapter 2. We're asked to find the mean, median, sum of squared deviations, variance, and standard deviation for the numbers below. So let's go ahead and organize the data. So here we have the data that's given to us. We have, skip my pencil writing here, x1, x2, x3, x4, x5, x6, x7, and x8. And the scores that were given, here we'll label the column X, are 6, 1, 4, 2, 3, 4, 6, and 6. And so let's understand the critical information we're going to need to solve it. We're going to need to know n, or the number in the sample. We're going to need to know the mean. We will need to know the sum of squares, the variance, and the standard deviation. And so let's go ahead and begin to work these problems out. So first off, we have the scores and we need to know n. And in this case, we can see that there are 8 individuals, so n equals 8. We need to calculate the mean. And we know the formula for mean. The mean is the sum of all the scores divided by n. And in this case, sorry about the triangle. I must have a functionality set to somehow create these shapes. And so I'll adjust that later. So the sum of all these scores divided by n equals 6, 11, 13, 15, 19, plus 12 is 31. And let me double check that. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20, 32. That sounds a little bit better. 32 divided by 8 equals 4. So the mean equals 4. The next thing that we have to do is figure out the deviations for each one of these scores. The deviations, as you know, is equal to x minus m. And so the deviation for the first score is the score x minus the mean equals 2. 1 minus 4 equals negative 3. 4 minus 4 equals 0. 2 minus 4 equals negative 2. 3 minus 4 equals negative 1. 4 minus 4 equals 0. 6 minus 4 equals 2. And 6 minus 4 equals 2. And next, we need to square each of these deviations. And I have some sort of a function marked that's turning those into shapes, so I will not circle them. So I'm going to make the little square signal here, so we know we're squaring these. 2 squared equals 4. 3 squared equals 9. 0 squared equals 0. Negative 2 squared equals 4. Negative 1 squared equals 1. 0 squared equals 0. 2 squared equals 4. 2 squared equals 4. And so now we have all the data we need to continue. What we do is we sum up these to get the sum of squares. In other words, the sum of squares equals the sum of all the deviations squared. And so in this case, we have this deviation squared. So we sum them up and we get 13, 17, 18, 26. Next, we can calculate the variance. The variance is simply the sum of squares divided by n. equals 26 divided by 8 equals 3.25. And our final step is to bring that down to the standard deviation. And we can simply take the standard deviation is the square root of the variance equals the square root of 3.25. And we have to use our calculator to solve that problem, or you can use a spreadsheet. And so we go 3.25 and we take the square root, we find out is 1.802, and I'll round up the 7, 2, and 8. 1.8028. 1.8028. And now we have everything we need except one piece of information, which is the median. And the median is the number that's in the middle of a ranked distribution. And so I'm going to rank the distribution here. I see 1, 2, 3, 4, 4, 6, 6, and 6. I have all 8 numbers written down, so I need to count over and find what's in the middle. 1, 2, 3, 4. I find these 2 4s in the middle. If they were different numbers, I would have to take the average, but since they're the same, the median is equal to 4. You're not asked to write anything for this problem, and I hope you found this little demonstration to be helpful.